Namaskar. I'm Rudra Kafle from Worcester, Massachusetts. Welcome to Physics is Fun 11th episode. Today I am going to do some fun experiments. Basically, I will be doing 4 simple experiments. Those experiments can be done with the equipments or the materials which are around our houses. Okay, so those maybe one of those experiments is a kind of repeated, so I might have already done, right? So these experiments are related to electric field force, okay, the force associated with electric field. Okay, so the first experiment I am doing is, by the way, I will be doing these 4 simple experiments in explaining the physics behind it. Okay, so I have these bits of paper, colorful bits of paper here, right, in this plate, in this plastic plate, you see, right, and I have a comb. Okay, these kind of experiments sometimes fail if the environment is wet, if there is a lot of humidity. So let's hope it works today. Okay, so I have a dry comb and my dry hair. So what I am doing here is I am bringing the comb close to the bits of paper. Nothing happens, right? You see, right? Nothing happens. Now what I do is I rub the comb against my dry hair for a few times. Okay, so I rub the comb against my dry hair. I am rubbing now for a few times, right? So bring the comb close to the bits of paper, and you see one bit has already been attracted. So let me try more, right? So after a while the charge leaks away, and so let me try one more time. Okay, yeah, see, another bit you can see here, another bit you can see here, right, like a heavy bit, a big bit, right? So let me try one more time. Yep. Okay, so this is all about electrostatics. I will explain the principle behind it after I finish my experiment. So that is the first experiment I wanted to demonstrate to you. Actually, I did in my previous episode too. Okay, so the next experiment is, so I have a soda can here, empty soda can, and you know soda can is made of metal, right? So I have this coaster here, right? So what I am doing is I am putting this soda can on top of this coaster. I hope you see, right? So it is at rest here. It is at rest here. So when I bring the comb close to it, nothing happens, right? Nothing happens. The soda can is still sitting there. Okay, you see that? Nothing happens. So let me rub my comb against my dry hair one more time. Okay, so please watch. I hope it works. Okay, it should work. You see? Okay, maybe there is not enough charge. Let me try one more time. Okay, sometimes there is not enough charge, that may not work. Okay, yeah, maybe I need to try one more time. Okay, so let me try one more time. So when there is not enough charge, of course there won't be enough force to roll the soda can. Yeah, it is slightly rolling, but not much. Okay, let me try putting on top here. Okay, so let me put on top of here. Okay, so just to make the visibility high. Okay, it's not enough, I believe. Okay, okay, I will try one more time. Okay, Yeah, it is simply trying to roll, but maybe not enough force. I'll come back to this experiment in a minute, but before that, let me do one more experiment. So I have this soda bottle, and this is the pipe, right? So plastic pipe to drink fluid, right? So I'm putting it on top of here. Okay, so I'll be rubbing this against my dry hair, right? I'll be rubbing it against my dry hair. So I put on top of the soda can, okay, and then I bring my hand close to it. Please watch. So you see that it is rotating, okay. Let me do the other side. You see it is rotating, right? I'm not touching it, right? You see it is rotating. Okay, I'll explain why that happens in a minute. Yep. So you see, it is rotating. Okay. After a while, the charge is lost, and so that may not work. Okay, so let me try one more time. Recharging. Okay, so let me put on top of this. Yep, see. Okay. Sometimes when the humidity changes, so that electrostatics experiment don't work properly, I'm trying to. Yep. So maybe there is more humidity now. I don't know. Okay. Okay. So the hair should be dry. Yep. See, it is working now. See, it is rotating. You see the rotation, right? Okay. So, so in the one final experiment I am doing is I am repeating. So, oops, sorry. Okay. So what I am doing is, so I will be. So I have a water bottle here. Okay. So I need to be careful because I don't want to spill water all over. So I have made a hole. I have made a hole in on the towards the bottom of this. Okay, towards the bottom of this water bottle. So probably you see the water is coming out, right? Probably you see the water is coming out. So what I do is now I rub my comb, right? My comb on my dry hair, and bring to the water streak. So please watch. Okay, so you can try these experiments at home. So the path of the water changes. Okay, you see. So please try these experiments at home. You can easily observe this, right? You can easily observe this. See, the water is attracted towards the comb. Okay, please repeat these experiments at home. These are very simple experiments. Okay, now let me go back to my my first experiment. So something did not work there. Maybe there was not enough force. Okay, so and then I will explain the physics behind is these all of these phenomenon. Okay, right. So let me clean up a little bit. There is all water all over. Okay, so what I do now is I'm trying to do the same experiment with the soda can. Okay, so let me put my soda can on top of this again. Okay. By the way, you can also rub the comb on the woolen cloth or something. Okay. Let me try one final time whether I can give enough charge. You can try these experiments at home. These experiments definitely work. I already tried, right? So Yeah, so maybe there is not enough charge in this case. I don't understand why it is not working. Okay, so let me try. Okay, yeah, maybe some like the rise of humidity or something, like there was not enough force, I believe, right? So please repeat these experiments at home, and they should definitely work, right? So now let me try to explain the physics behind it. So what is the physics behind it? I explain that here. Okay, so yeah, so what I showed you is the comb and paper beads. That was the first experiment, right? And we have a comb, right? So the comb has atoms. The comb is made of course, certain kind of atoms and molecules. They are neutral, right? There are same number of positive and negative charges. So the net charge is 0, right? So these are the paper beads. Exactly the same thing happens there, right? In the paper beads, there are same number of positive and negative charges. That means protons and electrons. So the net charge is 0. So in both of these objects, they are electrically neutral in the beginning. So when I rub the comb on my dry hair, right? So what happens that it and bring to the bits of paper, it attracts the bits of papers, right? Bits of paper, right? So why? The reason is what we call electric polarization. So what happens? Okay, let me explain this to you. Okay, so what happens that the both of these objects are insulators, right? Plastic comb is an insulator, right? On paper beads is also electric insulator. The charges don't flow freely. So what happens when I rub the comb against my dry hair, right? It gained some charges. By the way, in this picture, like the picture shows the negative charge, but the plastic comb also might be also positively charged. Whether it loses or gains electrons, it depends how on what kind of objects did I rub, right? So when I bring the charged comb, which I rubbed against my hair, right? So it now pulls the positive charges towards it, right? Because unlike charges, positive and negative charges attract each other. So in that case, what happens is the paper beads are polarized. So that means the net positive charge shifts, right? It doesn't move actually out of atoms, but the net positive charge shifts towards the comb, right? So because of that, the two objects attract each other. That means the comb attracts the bits of paper. Of course, according to Newton's third law of motion, the same amount of force is also exerted by the bits of paper on the comb, right? So that is what we call electric polarization. Okay. So now let's go a little bit mathematics, right? So for example, you did not see the soda can moving a lot. It's slightly oscillated, but you can try. Please try the experiment at your home, and then it definitely works. Okay, I did the other time, and it was working well, right? But you saw the pipe, right? The plastic pipe moving, right? So why does that move? Let's try to apply Newton's laws of motion, right? So how do we do that? So we know that F equal to ma. The force is equal to mass times acceleration. So in this case, what is the force? The force is what we call the Coulomb's force. Okay, the Coulomb force. So what is that? So when I rub the plastic pipe against my hair, right? So and brought my hand close to the pipe. So what happened? The pipe started moving, right? So initially it was at rest. Afterward, when I brought my hand close to the pipe, it started moving. So it started from zero velocity. In the beginning, it was at rest. Finally, it started moving, means it has now acceleration. So for acceleration, there should be a force. So where does the force come from? The force comes from the Coulomb force, that is the force between the charged pipe which I rubbed against my hair and my hair of my hands, right? So they are polarized. I just explained electric polarization, right? So that's what it happens, right? So because of that, the pipe is attracted towards my hand, right? So that gives acceleration. Hence, the pipe starts moving. Exactly the same thing will happen when you bring the comb, right, charged comb, close to the soda can, right? The soda can initially is at rest, right? When you bring the plastic comb rubbed against your hair, so it has now charged, right? So because of that force, Coulomb force, the force is now acting on the soda can, right? And then that gives acceleration, and then the soda can starts moving. Okay, it starts rolling. Okay. Now, this everything boils down to what we call electric field, right? So electric field is force per unit charge. Okay, electric field is force per unit charge. In the previous slide, we saw that force is equal to the Coulomb force K Q1 Q2 divided by R square, right? By the way, this R hat is just the direction, right? This is just the direction of the electric field or force, right? K Q1 Q2 over R square was the force, divided by Q2, so we can cancel Q2, so K Q1 over R square. That is simply what we call is the electric field, right? So that gives the we can write this way, right? The force in electric field is Q times electric field divided by the mass of the object. So that is the acceleration. So even if the objects do not touch each other, even if the two objects do not touch each other, because of this electric field on charged objects, right? The charge either developed by polarization, or you can give the charge. So there is a force F equal to Q times electric field, where Q is the amount of charge, E is the electric field, and divide by mass, that gives acceleration. So that is an application of Newton's second law of motion in electric field. Okay, in electric field, right? So why I'm calling here a field, to emphasize the fact that some forces are contact forces. For example, when you consider this object, right, the ball tied to a string, right? So I am applying force on the string because of contact, right? I am holding it, and the string is applying force on the ball because that is the contact force. That is it is tied to the ball, right? So there is a contact force which is tension, right? The same way, if you consider an object and another object moving or rolling on it, right? So they are in contact with each other. So that is what is the frictional force. Okay. So please try to repeat those 4 experiments. These are very simple experiments. You can try to repeat. You can do these experiments at home. So a comb. What you need a comb, bits of paper, right? So please do the experiments in a dry condition. If there is humidity, electrostatic experiments usually fail because charge immediately leak to the atmosphere, right? So in humid condition, electrostatic experiments usually fail, right? So another experiment is just a pipe, right? The soda pipe, right? This pipe, and then you can put it on top of any surface, and then do the experiment. And the third one was the water spout, water falling, and then bring the comb close to the water falling, like you can do with the tap also. One thing I would like to point out is when you bring the comb rub against your hair to the water falling, so there might be 2 kinds of the electrostatic force can be by 2 ways. Sometimes what happens, mostly tap water contains ions, right? So when I rub comb against the hair, so what happens? There is charge by friction here, and then there is already ion in the water. So those two, right, the charge in here and ions, which are charged particles, right? They may attract they attract that way by the Coulomb force, or water molecules polarize again, as like the what I explained for the bits of paper, right? So these there are clearly two kinds of forces I talked now. One is electrostatic force, which is the force associated with field, right? Even if the objects do not touch each other, so there is force between the two objects, right? The same way the gravitational field, right? In the same way exactly, the gravitational force is the same kind of thing, right? So same kind of force. For example, this object I am holding here, if I let it go, it falls down because of the Earth's gravity. Earth's gravity is not, Earth is not, even if the Earth is not exactly touching the object, the gravitational force acts through the gravitational field. So the concept of field is very important, right? So I hope I try to explain somehow. So there are, with every force field, every force is like electrostatic force or magnetostatic force or electromagnetic force or gravitational force. So there is a field associated with this. Electric field, electric force. Electrostatic field, electrostatic force. Magnetic field, magnetic force, right? Electromagnetic field, electromagnetic force, right? Gravitational field, gravitational force. So those are associated each other. So but one very important thing is, please don't confuse yourself. Force and field are not exactly the same thing, okay? For example, when you saw that electric field quantitatively is force per unit charge. The same way gravitational field is force per unit mass, right? So that's how we need to connect those two quantities. So please try to repeat those experiments. If those experiments work, please be happy. If they fail, right, so please try to explore why did they fail. For example, let me try, before I stop my video, let me try one more time. Why did this exactly not work? It worked. I mean, I do this demonstration every time, right? And then it works. So let me try to give more charge this time. Yeah, it did not. So let me do with a different comb. Okay. Yeah. Maybe there was not enough charge. So please try this experiment. If this it definitely works. Okay. So but it does not work if there is a lot of humidity or moisture in air. There in that case, what happens? The charge accumulated will be lost immediately in air. One final thing I would like to mention is, it is good to use comb-like structure like this than one solid object. You can also use one solid object like a ball or something like that, but it is good to use this. The reason is, when you give charge to the spiky regions, electric field is very, very strong. So that's why one of the strong recommendation by the weather people is, a meteorologist is, please do not go close to the fences, right? The metallic bars, metallic fences during thunderstorm time, because there is very high chance for the charge leakage in that case, and they might be easily caught by thunderstorm or lightning. Okay. With that, I hope I delivered something good for you. With that, I would like to stop here. So thank you very much. See you next time.